Start with our next review for force and motion. Today we going to review the last part, the final part for the chapter. So basically we're going to touch upon the topic impulse, impulsive force and weight, which is the final subtopics for the chapter 2. So first, define impulsive and the formula. So again, in physics, there's a lot of formula, and sometimes we use the formula to define the physics concept. So in case here, impulse has a formula. So let's write down the formula first, and then let's see how we're going to define it based on the formula. So basically, impulse, we give it the symbol big J equal to Ft equal to mv minus mu. So this is basically the formula is either you can calculate it based on F times T, force times time, or the mass times velocity, final velocity minus mass times initial velocity. So basically, how we're gonna define impulse? So we're gonna write it like this. Impulse is the change in momentum. So how's that related to our formula? So a change here means subtraction. Or in the case, final minus initial. So in our formula, we have final velocity and we have initial velocity. So momentum is actually the product of mass and velocity of moving object. So we already defined momentum before, P equal to mv. It's basically the product of mass and velocity of the object. Mass times velocity, thus we call it product for multiplication. So as simple as that. So let's move on to number 2. The lorry with mass 1000 kilogram moves with velocity 80 meters per second suddenly brakes and cause the velocity reduces to 10 meters per second. Calculate the impulse of the lorry. So let's write down the formula. J equal to Ft equal to mv minus u. We can also write the mv minus mu as the factorized form because we have the same mass. So we can factorize the mass, bring it forward, and then leave in the brackets the final minus initial velocity. So basically, we cannot use this F times T because we don't have force here and then we don't have time in the question, given in the question. So we have to use the normal formula one. So mass, 1000 kilogram. V, final velocity is 10 minus initial velocity is 80. So when we plug into the calculator, we got negative value. So negative 7,000 kilogram ms negative 1. Just marry the two units. Just combine the two units. So it's negative because we're slowing down. So the momentum is decreasing. Thus the change in momentum is negative. So let's move on to number 3. A ball with mass 0.2 kilogram being kicked with a velocity 70 meters per second, then being heading to cause it bounces back with 80 meters per second. Calculate impulse of the ball. So again, we don't have Ft here. We don't have force and we don't have time, so we can just use the same formula as above. But this time, we see that the velocity is increasing, thus the momentum is also decreasing. So we're expecting the change in momentum to be positive, thus the impulse to be positive. So we plug in the mass, which is 0.2 kilogram. The final velocity is 80 meters per second minus 70 meters per second for the initial velocity. So when we plug in, we got 2. kilogram meter per second. So we expect it's going to be positive because the velocity is increasing. So number 4, a ball hits with force 300 Newton with time impact of follow through is 0.02 seconds. So follow through is basically ikut lajak. So that's the meaning in the bahasa Melayu. So basically what it means is when we want to hit the tennis ball, we have to take a longer distance first. The racket here need to be swing backward a little bit before we hit the ball. So in order to increase the displacement, that's increase the velocity. When we increase the velocity, so the momentum also will be higher, and thus the impulse gonna be higher. And also we wanna learn after this, the impulsive force also gonna be higher. So basically, it's just the action we needed to do in order for the racket to swing the ball at higher velocity. Calculate the change of momentum. So calculate the change of momentum is basically impulse, the same meaning as impulse. Okay, let's write down the formula. J equal to Ft equal to mv minus u. So we cannot use the second, the normal formula here, but we will use this formula because we're given the force and the time of impact. So the force is 300 Newton. The time of impact is 0.02 seconds. So when we plug in that into our calculator, we will get 6 Newton second. Just marry, combine the two units. Also, we can write it as kgms negative 1. Also can. Doesn't matter here because both units are the same, equivalent. So number 5, golf ball with mass 0.045 kilogram is hitting by force 270 Newton with time follow through is 0.05 second. Calculate the speed of the ball. Okay, so basically here it doesn't give us any hint that it's going to be impulse or momentum or other kind of concept here that we want to choose a correct formula. Basically, that's what I mean. So we don't know what kind of formula that we want to use here, but since we have force, we have time, so means that we can use the ft formula, right? But also it can give us the mass and ask us to find the speed of the ball. So that means we also need this formula over here as well. Since both are impulse, formula to calculate the impulse, we can then combine two formulas and then rearrange as appropriate. So assume that we move the ball, we hit the ball initially at rest. So the u here will be 0. So it just become ft equal to mv because m times v minus m times u, m times u is 0. So mv minus 0 is mv. So we want to find the velocity, which is the speed of the ball. So the velocity here, so what's going to happen to the mass? It's going to be divided. Okay. And then we just plug in the values. 270 Newton times 0.05 second divided by 0.045 kilogram. And then plug in that into our calculator. And we will get 0.045, 30. The unit for velocity is ms negative 1. So it's quite difficult at first because we don't have any idea about what kind of formula that we want to choose here, and the question itself doesn't state any words like impulse. or momentum or impulsive force, weight or something like that. So basically when we have a collision here, then we have to use impulse or impulsive force, depend on the question. But here we choose impulse because it relates us the two sides of the formula. First, the question gives us complete information about F and T, and then it gives us extra information about the mass and asks us to find the speed, which is the velocity. So that means that we have to use impulse because the impulsive formula is can also be used, but it's not the correct concept here. Basically. Okay, so let's move on to our next question. Okay, so the next question should be impulsive force, which is the concept is quite similar. The formula is also quite similar, but it's the sudden the subtle difference here and there. So we look at the first question first, and then we see what's the difference between impulse and impulsive formula, impulsive force. So the first is define impulsive force and its formula. Again, we have formula so that we can use the formula to make a definition for impulsive force. So basically, force equal to mv minus mu divided by time. So that's the impulsive force formula. And when we see that if we bring the time here to the F, it becomes Ft equal to mv minus mu, and then it becomes impulse formula. So basically, in order to do impulse and impulsive formula, impulsive force problem, we can use just impulsive force formula, and then we can rearrange it to make it impulse formula as well, so that you don't need to memorize it too much. You don't need to memorize too many formulas, but basically you have to remember that the impulse has a form, has a symbol of J, and the impulsive force has a form, symbol of F. So let's continue with our question here. So since we have a lot of operation here, mathematical operation, so let's write down the first sentence here. Impulsive force is, so whenever we have a division and then time, division time means rate. So rate of whatever the numerator, which is change of momentum. Change of momentum. Or the rate change of momentum also are true. So this word here, the rate, only can be used when we divide by time, such as acceleration. So the formula for acceleration, we have v minus u over t. So we can say that rate of, and then when we have subtraction, it become change of velocity. So acceleration is the rate change of velocity. So again, we also have v equal to s over t. So the rate of displacement, in this case, we don't have change because the displacement itself represented the change. So we just say that just the displacement. So the displacement itself is actually the change of distance. So it's just the rate of displacement when we have time here. So also when we in form 3 also we learn about power, the energy over time, or the work over time, work done over time. So we can also say that it's the rate of energy, rate of work done. Also true here. Every time you see over time divided by time, then it's gonna be rate of something. Every time you see a minus sign, that means change of something, change of momentum, change of velocity here. So it's gonna be the standard terms that we use to define physical concept. So what? How about if we don't have time here? Let's say the pressure, also symbol P, equal to F over A. So here we don't have time at the denominator, so we just need to say that normal force over area or normal force per unit area. So also can be used here. So basically, if the unit is different than the time, then we cannot use rate. Then we have to use per unit something something or over something something. So let's see if we have, yes, density. Mass over volume, right? So we can say that density is the mass of object over volume. Or we can say the most accurate one is the mass per unit volume. Per unit is the correct term here. It should be used per unit. Okay, so let's move on. Choose and explain the best technique to heading the ball. So like always, we have to use follow through to increase the displacement here. The displacement is longer than this one. Thus, the velocity higher because formula for velocity is s over t. So when the displacement high, the velocity high. And the time of course smaller time, impact time is it. When the time smaller, the velocity higher as well. So when the velocity higher, the momentum E equal to mv also higher because V higher, P also higher, momentum is higher. Thus, the impulse also higher. Since U is, we assume at rest, so the mv is just the momentum. When the impulse is higher, then we can say that F, the impulsive force, which is J over T or mv minus mu over T, this formula are the same. So when impulse higher, yes, impulse higher, the impulsive force higher, as well the time. Time lower, then the impulsive force higher. Okay, so we must choose follow through. Okay, number 3. Diagram shows a car with mass 200 kilogram hits a wall with a velocity of 50 meters per second. If the crumple area lengthen the time of impact to 0.5 seconds, calculate impulsive force producers. So basically, time of impact, in order we want to decrease the impulsive force, we need to lengthen the time of impact. So let's write down the formula first. And V minus U. So as well as impulse, we can also write the impulsive force formula in factorized form due to the same reason as the mass is the same before and after. So if we increase the time, then the force will be reduced. Thus, it will cause less damage to the car. So the question asks for the impulsive force. We just use this formula. We don't need to rearrange. Just plug in the information needed. 200. The initial velocity is 15. The final velocity is 0. So 0 minus 15 divided by the time 0.5 seconds. So we get, when we plug in that into our formula, it should be negative 15 times 200 divided by 0.5, 6,000. Negative 6,000 Newton. Okay. So basically, what is the negative here? Why it is negative? It is because not the force is not due to the car. It's due to the wall. The wall exerted the force to the car. So thus the car experience negative force because it's push. It's mean push. The force seems like if you in the car, it seems like the wall push you towards you 6,000 Newton. Thus the car become crumpled. Okay. So if it is positive, then it's pull. The car exerted the force on the wall. Okay. Basically, this is also true F equal to 6,000 because due to the Newton's third law. Newton's third law of motion. Because every action will cause reaction with the same magnitude but opposite direction. So if the wall exerted a force on the car by 6,000 Newton, the car also exerted a force on the wall by 6,000 Newton but opposite direction. In this case, positive. Okay. Diagram shows two situations, case A and case B. Given the mass of the man is 60 kg and the final velocity when his foot land on the ground is 0.5 meter per second. Okay, that is the final velocity. So when we write it B, so time of impact given for both case. Calculate impulsive force for both cases. So let's calculate A first. M equal to V minus U divided by time. So we assume that the initial velocity is 0 here. It started from the rest and then come to 0.5 meter per second. So let's plug in the value of mass and the velocity 0.5 and the time of impact 0.02. So we get FA become 1,500 Newton. Okay, that's for A. Let's see for B. Same formula. So same mass, same velocity. Final velocity, initial velocity is 0, but the time impact is longer. So what happened to our force? It should be lower than A. 100 Newton. So thus, it is safer that we bend our knees when we jump and land. If we do like this, then the force exerted on our feet by the ground is higher, that can cause damage or injury to our knees. Okay. So which situation can cause injuries? Is A. Okay. So we already discussed about that. So let's see the last subtopic. Okay, so let's move on. So the last subtopic is the weight. This is quite simple and the formula is also simple. But in this case, we cannot use the formula to define the term here. Let's see why. Okay. So the weight, what is meant by weight? So if we know the formula for weight is equal to W equal to mg. So it basically comes from F equal to ma. So F is the weight because weight is the force, vector quantity, and A is the acceleration for G. G is the gravitational acceleration due to the Earth. Okay. So why we cannot use the formula to define the weight? Because these two formula has kind of the same situation here. We cannot also use this formula to define force because force is defined based on the Newton's second law of motion. Newton's second law of motion. So based on the Newton's second law of motion, force is directly proportional to the change of momentum, and it has the same direction as the acceleration of the object. So basically that is the definition. The formula is not directly from the Newton's second law, it's data come from the Newton's second law. Basically the formula is actually the rate of change. Here it comes from the impulsive force formula basically, but we change it into F equal to ma. So because v minus u over t is acceleration, thus it becomes F equal to ma. So we have to be careful here because we cannot define it as as because F equal to ma comes from this formula first, and then this formula comes from the Newton's second law of motion. So how are we gonna define weight then? So we know that force has a lot of types. We have impulsive force, we have weight, one of them, we have buoyant force, we have normal force, we have thrust, we have friction. So a lot of force. So all of the forces can use the same formula here at FWA, but since they have the same kind of same form of the formula, same type, mass time acceleration, then we can use the formula as the definition. Gonna be confusing. So what we're gonna do here is gonna be weight is a force acted on an object due to gravity. Okay, or we can say that weight is a gravitational force acted on an object. That's more specific in terms of it is a force, and then what we define is what kind of source the force come from. Is come from the gravity, the gravitational force. So weight is the gravitational force acted on an object or the force acted on an object due to gravity. So we don't use the formula here. Same as friction. Friction is type of force. It can be used F equal to ma as well, but we cannot use the formula to define the friction. So we can use here. Friction is a force that acts oppose the movement of object, because that is the definition of friction. When we have a movement in one direction, then the friction is automatically there in the opposite direction. Okay, so far so good. Make sure that if the term related to force, a type of force such as weight or friction or buoyant force or thrust or tension throughout the spring or something like that, then we cannot use the formula. We have to be specific where the force comes from. Okay, we have to state that. So what is the differences between weight and mass? So we can make a table here, but we don't have so much space here, but we can make it simple, even though we don't have so much space. Weight is a vector quantity, whereas mass is scalar quantity. Weight also a derived quantity. Mass is base quantity. Okay. Weight has direction. Mass does not have direction. Weight can be measured using spring balance. Mass can be measured using triple beam balance. Weight has a unit of Newton. Mass is a unit of kilogram. Weight can be different at different places. Mass same at all places. So that is the difference between weight and mass. So mass is constant properties. It cannot be changed. Whereas weight can be different if we at different places, such as at the moon. So let's see, number 3. A man with mass 60 kilogram, okay, calculate the weight of the man on surface of the earth. So we have to use the value G here. G equal to 10 Newton per kilogram. So this is the gravitational field strength. Okay, because the unit is Newton per kilogram. If the unit is ms -2, then we say that it's gravitational acceleration. The value, the number is the same, but the unit is different. So W equal to mg. M is 60 kilogram. G is 10 Newton per kilogram. So the kilogram we cancel out, it becomes 600 Newton. So number 4, given Earth gravitational acceleration is g equal to 9.81 meter per second square. Moon gravitational acceleration should be lower, which is g equal to 1.64 mass meter per second square. Why is lower? Because the mass is lower. Moon and the Earth. For a man with mass 80 kilogram, calculate weight on the surface of the Earth. So same formula, but we have to choose the correct G here. So we choose G on Earth. So the mass is 80 kilogram and G on Earth is 9.81 ms negative 2. So when we calculate that, it becomes 784.8 kilogram ms negative 2, or it's also true that we write it as in Newton. So the Newton unit here is the same as kilogram meter per second square. Weight on the surface of the moon, so that W equal to mg. So here we have to use the gravitational acceleration on the moon, which is 1.64 meter per second square. When we plug in that into our calculator, 1.64, it will come up 131.2 Newton. Okay, so weight in the ISS, which is in the space, is equal to 0 because we don't are in the space, we don't have mass. And say we don't have mass is in terms of the space itself. The space doesn't have mass, doesn't have gravitational force or gravitational acceleration, but we have mass. The object itself in the space has mass, but the space itself doesn't have mass, so the space cannot interact with us. Thus, we experience weightlessness. Weightlessness. We don't experience weight, so we floating in space. So, like we said earlier, weight is actually the gravitational force experienced by the object. So in this case, this amount of here, 784.8 Newton, is the gravitational force experienced by the man on the Earth. Okay, 131.2 Newton is the gravitational force experienced by the man on the moon. Okay, whereas we don't experience any gravitational force if we in the ISS because there is no mass, two mass to be interacted with, so no gravitational force. Okay, let's see number 5. The weight of an object, the Earth, is 500 Newton. When the object placed on the planet X, the weight becomes 200 Newton. Okay. Calculate the gravitational acceleration G for the planet X. So let's see what we need here actually. So we need the G for planet X, but we don't know the G yet. But what we can do here, since it's given us the weight on the Earth, we also know the value of G of the Earth, right? So we can find mass. Because we said earlier that the mass is constant everywhere, even though you are on Earth, on the moon, or on the planet X, the mass doesn't change. So in proof that we can use that mass times the mass and the gravitational acceleration for the planet X to get 2000 Newton. That's our proof here. So let's see. We arrange the formula. Mass equal to W over G. So W on Earth is 500 Newton. G on the Earth is 9.81 Newton kilogram negative 1. So we can use um, the gravitational field strength here. Okay, so 500 divided by 9.81. So it becomes 50.6, 50.97 kilograms. Okay, we know the mass, then we can use that mass to find the gravitational acceleration. So again, we use this formula and then rearrange the G, it becomes weight over mass. So weight at planet X 2000 is quite massive. The planet X is because the force exerted, the gravitational force exerted on the same object is bigger. Thus, we assume that the mass of the planet X is bigger than Earth. Okay, so the mass is 50.97 kilograms. So our G is 2000 divided by 50.97. We got 39.24 meter as negative 2 because it has the gravitational acceleration. Then we have to give acceleration unit, even though it had the same value as the gravitational field strength. Then we have to be specific here. Okay, let's see the final question. On the moon, the weight of the object is 82 Newton. Calculate the mass of the object. Okay, so how we going to calculate the mass of the object? We have to use G of the moon. So when we see that, when we scroll upwards, it's already given us the moon acceleration here, the gravitational acceleration 1.64. So let's just use that. Okay. So W equal to mg. We arrange the divided by G. M equal to W divided by G. So 80 Newton divided by 1.64 Newton per kilogram. So 1.64, we got 48.78 kilogram. Okay, so as simple as that. And I think that's all for today. Hopefully that you understand all the concept in this chapter. Because this chapter introduces a lot of concepts, introduces three laws, Newton's first law, second law, and third law, and also give us a hint about gravitation chapter that will come next. So especially the gravitational acceleration and the gravitational field strength, also weight. So all of these three terms here is related to the gravitation chapter for chapter 3. So hopefully that you understand well the concept here, understand what the formula means, and understand how to use the formula to define physical terms and how not to use the formula to define physical terms such as force. So force has a different type, then we have to be specific. Okay, otherwise we can use the formula to make a definition. Okay, that's all for me for today. Stay tuned for the next chapter.